Okay, so here is another problem on our solve problem series, and this is on logarithmic inequalities. And this is not a usual logarithmic inequalities because the missing x, or the solution set that we want to find, is on the base. Okay, usually the x are in this expression or on this side, but this time the base is missing. Okay, and it could be a set of numbers. So how are we going to solve this? Let's watch the video. Okay, so first thing to consider when you solve logarithmic inequalities, as we know, because x is the base, x must be greater than 0 and x cannot be equal to 1. This is a condition on the base of logarithms. Okay, so we can never have a base that is a negative number and the base cannot be equal to 1 as well. So when we solve this inequality, we expect that our x must be a positive number and we cannot include 1. That's the meaning of this condition. Okay, but we will see later on what will be our final solution set. Okay, so here the actual solution, the log base x. Okay, so copying the expression 1 over 125 less than or equal to negative 3. The trick is you have to rewrite this with a log. Okay, so what we will do is we will multiply negative 3 by 1 in the form of log base xx. Remember this special rule, the log base x of x is equal to 1. So we can multiply negative 3 by 1 without changing, without altering the inequality. Okay, so with that, because you have log base x of x and there's a number here, by power rule this number can be the exponent of x. So our logarithmic inequality becomes log base x of 1 over 125 less than or equal to log base x of x raised to negative 3. And from here you simplify that negative exponent or expression with a negative exponent, properties of exponents, it becomes 1 over x cubed. Okay, and then this is the time that we will be relating these two expressions. Okay, and let me take you to a quick review what happens if we have log base b of m and then less than or equal to log base b of n. So there are two things that can happen. Case number 1, m is still less than or equal to n only when the base is greater than 1. In other words, the inequality of the log is preserved for m and n when the base is higher than 1. However, m is less than or equal to n when the base is between 0 and 1. Greater than. So the inequality is now reversed. Okay? So with that, okay, we have two possible cases. So take note of our cases. So case number 1, as we can see, the base is between 0 and 1. In other words, the x, which is our base, is between 0 and 1. So copying what we have from this step, so log base x of 1 over 125 less than or equal to log base x of 1 over x cubed. Relating these two, okay, you can see them here. The inequality is reversed because we have assumed that the base is between 0 and 1. Therefore, 1 over 125 is greater than or equal to 1 over x cubed. And then we continue. If we multiply both sides by 125 and x cubed, 125 and x cubed, and since x, remember the base x is greater than 0, we are sure that this is positive. So the inequality will not be reversed when we multiply it by 125x cubed. Therefore, 125 will cancel with 125. X cubed times 1 is x cubed. X cubed cancel. 125 times 1 is 125. And from here, solving x cubed greater than or equal to 125. Okay, let me just explain something. If this was an x squared greater than or equal to 9, do not just take the square root of 9. You will not be able to get the whole solution. Instead, you have x squared minus 9 greater than or equal to 0 to be factored in the form of x minus 3 and x plus 3, and then just continue solving this inequality, probably by table of signs or by using a certain technique. Now, it is different when the exponent is an odd number. Okay, this is an even number. It's more restricted. You cannot just take the square root. Okay, if it's a raised to 4, you cannot just take the fourth root. But for the case of 3, 5, 7, all these odd exponents, you can just directly take the root of both sides. Okay, so keep that in mind. So you can take the cube root of x cubed as x. Cube root of 125 is equal to 5, giving us x greater than or equal to 5. Okay, now this is supposedly the solution by this, or by considering this condition, the solution of the inequality with this condition. It is saying x must be greater than or equal to 5, but the assumption is x must be between 0 and 1. So this is not part of 0 to 1, so this is like an extraneous solution. Seems to be a solution, but because there is a condition that restricts the x, we cannot accept x greater than or equal to 5. Okay, so but 0, x is between 0 and 1, no solution here. So our hope is in the case number 2. Case number 2, the base now is greater than 1, meaning to say x is greater than 1. We copied the same expression, log base x, 1 over 125, less than or equal to log base x, 1 over x cubed. When you relate this to, so 1 over 125, 1 over x cubed, since the base, this is the base, that's our base, when the base is greater than 1, you have to preserve the inequality from less than or equal to the same less than or equal to. Again, multiplying both sides by 125x cubed, 125x cubed, you will end up with x cubed less than or equal to 125. Again, it's an odd number. We can take the cube root of both sides directly, ending with x less than or equal to 5. Since x is greater than 1, okay, 1, there's 5. Base condition is x greater than 1. Solution says less than 5 or equal to 5. So the final solution set is between 1 and 5, including 5. So we didn't get anything from case number 1, but we have something from case number 2. And that means that's the solution set that we are looking for. That's x is between 1 and 5, including 5. And you can also write that in interval notation as 1 to 5 with a bracket on the 5 and an open parenthesis on the 1. Okay? So let me just give this as a warning. When you are working with logarithmic inequalities, some of you might be tempted on doing this because you probably came from solving equations. You might think of just converting it to exponential form, x raised to negative 3 and then less than or equal to 1 over 125. Okay, so the problem with that, as you can see, is it doesn't include all the possible solutions, because this is just the case of 1 over x cubed less than or equal to 1 over 125. So do not do that. Okay, so do not just convert it to exponential form. You have to consider the cases, okay, which I explain in this solution. Okay, for equations, that's fine. Okay, inequalities are more restricted, particularly the logs. Okay, so do not just convert to exponential form. So I suggest you use the cases. Okay, identify there are just two cases. Identify the two cases and work on each assumption. Okay, we're using each assumption between 0 and 1, then higher than 1, what happens to my logarithm or logarithmic expression, an inequality, and what happens to my expressions. Okay, and there's a side note here. Watch out for even exponents and odd exponents. Some can be taken directly through the roots, like the odd exponents, but be careful with the even exponents. Okay, so I hope that you were able to understand how to solve now an inequality in this form. If you are confused with some of the parts, this is a video. You can always go back to that part and listen again to my explanation. And aside from that, this is uploaded in the channel. You can always type in your comments, okay, or questions if there are things about this video that is not clear. Okay, so that's all. Thank you.